Holliday and Resnick, Chapter 6, Problem 16. A loaded penguin's sled weighing 80 newtons rests on a plane inclined at 20 degrees to the horizontal. Between the sled and the plane, the coefficient of static friction is 0.25 and the coefficient of kinetic friction is 0.15. What is the least magnitude of the force F parallel to the plane that will prevent the sled from sliding down the plane? B, what is the minimum magnitude F that will start the sled moving up the plane? And C, what value of F is required to move the sled up the plane at constant velocity? We'll start with a free body diagram of the penguin in the box. Normal. By now we know that this is mg cosine theta. mg. And this is mg sine theta, which we usually show here. And we're going to have a force pulling in the opposite direction of Fk. And also we have a given force. And we want to know the force required to hold this box static. So this force will be Fs, because it's not going to move. So first, when we sum our forces, we're going to have mg sine theta minus f of s minus f equals ma. Now we know that it's static, it's not going to move, so ma is going to equal 0. So we have the force that we're looking for. We want the minimum force. It's going to equal to minus mg sine theta, taking it on the other side of the equation, plus the frictional force, F of S, which go to F equals mg sine theta minus F of S. And we know, so we have F equals mg sine theta minus mu s times n, and n is just mg cosine theta. So we'll plug these values in. We have 80 newtons times the sine of 20 degrees minus the coefficient of static friction, which is 0.25 times mg, which is 80 newtons, times the cosine of 20 degrees. And we'll pause and do the math and see what happens. 8.56 newtons. That's for A. All we did was sum all our forces in the x direction. We had F that we were looking for, and we had mg sine theta. We made that in the positive direction. Minus F of S minus F that we was looking for equals MA. And since it was static and it did not move, the acceleration was 0. And then we just solve for F. And we got 8.56 newtons. B is, what is the minimum magnitude F that will start the sled moving up the plane? So for B, we have our penguin in a box. Try to draw him. And we want it to move up the plane, and we want to know the minimum force. Well, we'll have mg sine theta, and also in this box we'll have Fs, the static friction. So if we add these two forces, that'll give us the minimum force required to move the box up the plane. So we have, let's just do this free body diagram. So we have N, we have mg cosine theta, and we have mg sine theta, and also we have, in this direction, F of S, the static friction. So N minus mg cosine theta equals MA, and we know it doesn't accelerate in the y direction, so that's 0. So N is going to equal mg cosine theta, and mu n, which is Fs, is equal to mu times mg cosine theta. So mg sine theta is equal to 27.36 newtons. And mu n, which is 0.25 times 80 times the cosine of 20 degrees is equal 18.36 newtons equals the friction F of S, the force So we have 18.36 in this direction, and we have 27.36. And when we add those two together, we get 46.15 newtons. So the answer to B is 46.15 newtons. You have to overcome that force pulling this way in order for the box to slide up the hill. We just simply took the frictional force and the force mg times sine of theta that wants to slide that, added them together, and that's the force you have to overcome. C, what value of F is required to move the sled up the plane at constant velocity? Okay, we have our box. Do our free body diagram on it. And we have mg sine theta. And we want to move it at constant velocity. So we're going to have to overcome the frictional force, which we have because it's moving at constant velocity. So the only force we're going to have is mg sine theta. And we're also going to have F mu k. That's the kinetic coefficient of friction. So we have to figure out F mu k, we go N minus mg cosine theta is equal to ma. You know the story by now. Doesn't move in the y direction, so that's 0. So N is equal to mg cosine theta, and F of k, which is equal to mu n, is equal to mu mg cosine theta. So we want to move it at constant velocity. So let's sum our forces. We're going to have mg, and we're going to make this direction positive up the plane. So we're going to have minus mg sine theta minus mu mg cosine theta, and we're going to have plus F is equal to ma. Now, since it's constant velocity, we have no acceleration. So this term here is going to be equal to 0. So we can solve for F, and F is going to equal mg sine theta plus mu mg cosine theta, and this is equal to 80 newtons, that's what mg is, times the sine of 20 degrees plus mu, which is given to us as 0.15, 0.15 times 80 newtons times the cosine of 20 degrees. And this is going to equal 38.63 newtons. Part C.